Okay, so now we're getting to some of the simpler things in life. You have the frequency tables to categorize and understand some of your data. Now we're going to talk about displaying some of your data. When you want to display qualitative data, it's important that you understand which one's which. When you want to display qualitative data, then you're going to want to use bar graphs and pie charts. Hold on a second. This helps. A bar graph, not that I didn't know that, but anyway. A bar graph uses a set of bars to represent the frequency or relative frequency for each category. The higher the frequency, the longer the bar. You've seen these a lot in your life. The table below shows beef production of the 6 largest beef producers in the world. Some interesting stuff here. I'm going to let it go. So they're going to want you to draw the bar graph. We don't want you to be able to draw a bar graph. That's not what we're after. We want you to understand a bar graph. So we're going to draw a bar graph together so that you can better understand how to read a bar graph. That's what I need to make sure you can do, is read a good bar graph. Because if you can't read a good graph, you're never going to be able to understand the good graph. And that's what's really important. So when we're talking about a bar graph, we have bars that are across the bottom, and across the bottom we're going to put this information, which is all of our word stuff. So we've got the US, we've got Brazil, we've got the European Union, we've got China, we've got India, and we've got Argentina. Okay? And they're talking about the amount of million metric tons of beef. Wow. I can't believe the U.S. is the top producer. We'll talk anyway. Probably won't talk about that. So most of the graphs that you look at are going to already be drawn for you. So I'm not going to go into how I'm getting the numbers at the side. I'm just going to go ahead and write them. 3, 6, 9, and 12. So these are obviously talking about metric tons. So when I say 3, it's going to be 3 metric tons. When I say 6, it's going to be 6 metric tons, because this is in million metric tons. So it's 3 million metric tons, 6 million metric tons, 9 million metric tons. So the US is up to 12.4. I don't want to just go up to 12 for the US. I got to go a little bit above that. But I don't want to go way up here, because that would be 15. But I can't just let it go. I can't let it go like a third, because a third would be up to 13. And that's not right either. So it's just a little smidge above 12. And I draw my bar. Now it doesn't matter how wide the bar is. We're not concentrating on that. It doesn't matter what color it is, none of that. Because you're not drawing this, you're just going to be reading it. But I need you to understand that some of these point ones and stuff, they're not there to mess you up, but you've got to understand when you're reading them. So for Brazil, it says 10.1. This is 9. That is not 10 up there. Up here is not 10. 10 is going to be a third of the way up. So if that's 10, I need to go a smidge higher for my point 1. And then I can draw my bar. For the EU, it's 7.8. So I don't want to go just up to 6. I got to go up to 7. I don't want to go up to 8, but a little bit below 8. A little bit more than halfway. .6. More than 6. Not up to 7. India, 3.7. Not quite 4. Argentina, 3.2. Over 3, but not up to 3.5. Definitely not up to 3.7. Do you understand? The numbers are going to go on the side. The words are going to go across the bottom. The bars do not touch. That matters. Pie charts are used primarily for relative frequencies because the total pie must always represent the total relative frequency of 100%. The size for each wedge is proportional to the relative frequency of the category it represents. The wedge angle relative frequency is 360 degrees. So basically, all of this together generally represents 100%. So we can tell that this one is not going to be, because they got lots more than 100%. This one down here, you can tell that it's not this one. Because the mushrooms are smaller than 21%. Black olives are smaller than 23%. Doesn't add up to 100%. So it can't be that one. So it's got to be one of these two. And the only way to really check it is to go ahead and figure out the percentage of something. So I'm going to figure out the percentage of mushrooms because my mushroom numbers are different. I didn't want to figure out the percentage of something else. I could have, I'm sorry, I marked out the wrong one. Oh. This one is the one that I needed to mark out. That it couldn't have been, because that's not 50%, that's 50%, not 47. So this one it could be, but I don't think that adds up to 100%. I don't think that adds up to 100%. 47, 21, 23. I'm going to check it. Oh, it does. Okay, fine. So it's between these two now. I'm going to figure out the mushrooms. Because the mushrooms are different. The onions are the same. The black olives are the same. The pepperoni is just off by a little bit, just like the mushrooms are off by a little bit. You could figure it out by the pepperoni, but I'm going to figure it out by the mushrooms. So I'm going to take 150 and divide it by the total. So first you have to figure out what the total is of all of those. So when I add them all up, I get that my total is 790. So I'm going to divide 150 by 790. And when I get that, I get 0.189 times my 100% gives me 18.9%, which is 19. That's why it's C, not D. I knew which one it was, but you know. Histograms and line charts. Histograms and line charts are used with, I can talk. They're used with quantitative categories. But I think we're going to do it in a different recording. I'll be back.